in 99% of the conversations, we actually tell our customers, stop building your data collection efforts. That was last decade. If you buy one of these robot arms instructions, they literally say only use a yellow wood looking table, change that tabletop, that model would not function. There's a big technology gap.
Ash, coffee, tea, or something else? What fuels your mornings?
I think it's coffee, one in the morning, one in the afternoon.
Keep it going.
Trying to keep it to two though.
Two. Yeah, I find myself if I have them too late in the day, it's like as much as I'm not as sensitive to caffeine, but you do notice it at night time trying to sleep, and my brain's always running crazy anyway. When you were a kid, what did you think you'd grow up to be?
I think I wanted to be a inventor. So I was playing around with robots even when I was a kid.
Really?
Yeah.
Oh, cool. How did that come around?
It was fun. So I got a kit where you can assemble these electronic parts. Along with we used to have those tape recorders or walkies where you can listen to music. They have motors, so we were able to break them apart, make a robot out of it. That was fun.
That is very creative. So you were on the path from young. What's one technology that you can't live without?
I think these days it's really about the agentic workflow I have built personally for myself that I'm using it for many, many things. So it has become the new electricity for me.
Yeah, that's awesome. Were you, I'm assuming, like an early adopter as all of this was coming out, like tinkering, building, trying out all the different options that the market has to offer?
So I think I've been in the area of AI for about last 20 years, did my PhD at Stanford with Andrew Ng. So we built many of these models. In fact, we built that 2017 model that puts vision, language, action into a very large architecture. But what caught me by surprise is the sudden jump that we started seeing in 2023. So when you start tinkering and using it for your own personal use, uh, that was new. That was very impactful.
It's crazy seeing how much comes out even on a weekly basis now. It's mind-blowing to keep on top of all of it. It's pretty overwhelming.
Right.
Last one, if you could fast forward 10 years and see one impact that your work has made on the world, what would you want that to be?
I think we want to have robots do really useful tasks, uh, way way beyond the simple pick and place or machining tasks that we are looking at today. So we want our AI to be driving physical systems throughout the world, whether it is large machines like agricultural tractors or mining machines to humanoids. Uh, Next 10 years, we will see TorqueAGI building the most impactful foundation model for robots.
Amazing. Well, welcome to Machine Minds, everyone. I'm your host, Greg Terusian, founder of Samson Rose, your robotics talent search partner. And on today's episode, I'm joined by Ash Saxena, founder and CEO of TorqueAGI. Thanks for being on the show today, Ash.
Yeah, looking forward to it, Samson. Thanks for inviting me.
My pleasure. So you've had the long track record across AI, data, enterprise software, and as you mentioned, like academia as well. What were the key inflection points that pushed you towards founding companies versus, staying as an operator or being an employee somewhere else?
I think whenever we see a big change happening in technology that opens up a new market, uh, that is a very powerful inflection point. So, for example, in my one of the companies that I founded was called Catapult. It was AI applied to uh, a particular area of lease to purchase, where you have about 32% people in the US who don't have access to credit cards, whether they're a student or belong to a certain segment of population. And something as simple as buying a crib or a bed online was not possible for them, right? Like you can get lease to purchase offers from physical brick and mortar stores. Now, what AI had done is it made underwriting possible. It can parse a large amount of data about making good models about which people have a good behavior of returning. And that led to us finding founding Catapult, uh, and creating that impact where now it became a public company, and it's available on any online retailer that you can go. Uh, in another example, I think what is happening is, especially in robotics area, which we are going to talk a little bit about today, the AI can become very capable. There is a huge demand, and suddenly you are looking at a huge unlock in the market.
Mm. Yeah. Yeah. Very true. You've built and scaled multiple businesses, as you mentioned. What did you learn the hard way the first time that you refused to repeat this time around?
So in the first company that I started with and doing, it was called Zunavision. It was a very technology first company. Uh, and what happens with technology first is you are kind of building a hammer and then looking for a nail. So after building a couple of companies, what we have learned is that you have to put technology, but you have to attach it to the demand or the use cases. So building a company is always about building a very powerful R&D organization within the company which can build the technology, but also putting it together with a powerful product term which is tied to business and ROI and dollars. And that's when a company really scales and could go better, especially in the market today where AI can support so much. If you choose it right in a scalable manner, it's hundreds of billions dollars of worth of opportunity, right? Possibly trillions.
Yeah. Yeah. Very true. You touched on this before about that inflection point with AI 2023. How is your view of AI from someone who's obviously been in this space for decades? How has that evolved from that earlier data analytics wave to what we're seeing today with like foundation models and embodied intelligence and things like that?
So when I started in 2005, with during my PhD with Andrew Ng, we brought the change from converting it to a small statistical AI, which is like linear regression, to larger models, starting from random fields to neural networks. We wrote the first paper in robotics on deep neural networks for robotics related to grasping and so on, in back in 2009. After that, YOLO became very popular. It's one of the techniques you use to build detectors. So that second phase, which we saw last decade, was about you now no longer write very clear input-output equations. You can instead take a data-driven way where you have a large network, but it is still input-output focused. You give it certain types of input, you get an output, and for that you need large amounts of training data. um, Convolutional neural networks, deep neural networks, many names, right? Um, there were other techniques as well, reinforcement learning, but they were, I think, really operating in theory. No one really used it in practice, right? Um, there was a very strong value to that type of AI because you can take a specific problem. The pattern was choose a problem, choose a very specific input and very specific output, train a very large model, collect a large amount of data, and that became a very template project, right? You kick off a 2 year project, data collection, input output, training, and here you go, here you have an AI. So whether you are building a spam filter online, you are building a recommendation engine on a movie streaming website, or you are building a detector for a security system or a robot, all followed the same pattern. Now, then what started happening towards the end of last decade is that some of us started bringing this change on how can we bring a general model that can do multiple things. So one of the very early papers we wrote was with Daphne Collar, Andrew Ng, and some professors at the Stanford group, where we called it combined classification models. It's like, oh, now you have four different tasks, and you can actually do multiple tasks, and improvement in one task improves the second, and improvement in second improves the fourth, and that became very powerful.
Mm.
That was not as powerful as the attention mechanisms, which deliberately have a reasoning and thought process on where to fix the attention, but at least it showed the sign of, oh, you can do more, right? Then, as a professor at Cornell, I was running a project called RoboBrain, popularly known as Wikipedia for robots. We showed that a robot learning from Cornell about household tasks uploads its knowledge. Our partner at Brown and our group at Stanford can learn from it. It downloads the learning at Japan. So that was another sign that now you can put vision, language, action into one model. It was the best paper at CDPR. But coming back to your question, what really changed, which is publicly visible for me, is now the complete equation has flipped. Now you are no longer building a specific AI, you are no longer needing to collect a large amount of data. Counterintuitively, now what you can do is have a model, and within minutes or days or weeks, you can build a functional AI. So the model remains
Mm,
the same. Instead of training the AI, you just have to say input and output as a prompt, set it up in a working manner, and here you go. You have solved an entirely new class of problems that used to take 2 years. So this is a massive shift from 2 days or 2 weeks to versus 2 years, right? Now
yeah,
that's happened in digital AI so far, not in robotics yet.
coming. It's coming. Well, let's shift gears onto Talk AGI, because obviously there's a lot of noise in AI right now in general, and you've touched on a few things there. But if you strip everything down, what is Talk AGI building, and how do you communicate that to general public?
So at TorqueAGI, we are building a model that solves end customers' problems. So there's a lot of noise because people talk about physical AI, world models, infrastructure, and so on and so forth. But if you really strip it backwards from what robotics people need, it's really about, oh, I have a robot, I have certain infrastructure. That's what they usually have. They're not usually interested in a new library or a model. They're interested in a solution, which is I have a robot. Can it pick up torts like you're seeing on the TV in the back in an automotive factory? Can it do that task? Some people are calling it skills. So at Torque AGI, we are building that skill, which is a combination of foundation model, agentic architecture, and certain level of AI infrastructure work that makes it work in real time. And it delivers that full end-to-end solution to the customer. And now a robot can do those new things, right? It's very opposite to some of the other companies who are building just the model, or they're building a data collection mechanism or a simulation mechanism.
Mm, mm, interesting. So, who would you say right now is feeling the pain the most today for what you're trying to solve for?
I think one of the there are two pain points, right? Like it's kind of a corollary that robotics companies are trying to unlock new use cases. So imagine that in a warehouse setting, there are six different tasks to do: unloading a truck, then mixed SKU palletizing, uh, putting it in bins, maybe doing light assembly. And another example we can take is a automotive car assembly scenario where you are putting things together to assemble
Mm,
small car parts. Now the problem is there's a big technology gap. So the robots are capable, so you can teleoperate them to do things, but you cannot have them work autonomously. Now the first thing that comes to mind in 99% of the common wisdom is, hey, let's collect data. In fact, we are seeing a massive number of startups and hundreds of millions of dollars focused on collecting the data. And that is really a massive problem. While you have billions of revenue potential, you are requiring at least hundreds of millions of data collection, thinking it will unlock billions. But that at all KGI, that's not the approach. That's not how we think about it. We believe the models are very close to human capability if you build them right. What that means is that if a human can build from 10, 50, 100 examples on how to do the task, maybe AI only needs 100, 500, or 1000, but it cannot be a million examples for training. So, at a kind of going back to your previous question, last decade was about data driven AI. This decade is about reasoning based AI. And in 99% of the conversations, we actually tell our customers to stop building your data collection efforts. That was last decade. Now we are saying, how can we get you going with the least amount of data possible, which in some cases, you might just take an iPhone camera and give us a shot of what you're trying to do, and that sometimes could suffice to get started.
Wow. That's powerful if it can be as simple as that, because I think for a lot of companies and even individuals, right, the hurdle to overcome to adopt new technology or even try to get the first part integrated into their system can sometimes be daunting if they've never done it before. They don't have anyone on hand to do it. So if everyone knows how to use an iPhone camera, if you can do that, send it over to us and get the ball rolling. I think that's huge. How do you? This is an interesting one, but how do you think about the gap between AI demos and real world deployment in what you're doing? Because we've seen so many of these fancy, great things for social media and great things for the press that go out there, and it gets people's eyeballs, but how much of that is like useful in the real world?
So we take a very pragmatic view to what can be done today, what can be done in a year, and what is far out for more than 5 years. So I think things that I'll go kind of backwards, right? So in 10 years, 20 years, I am very bullish on robots that can do a lot of things, right? They can go out and perform a lot of things. I'm not so bullish on the same robots doing things in households. There are serious problems with safety and supplyability. That might be more like 20 years out, right? But 10 years out, there are so many factory things that robots can do. Now you go backwards and say, okay, well, which task can it do today, and what can it do in 1 year, and what can it do in 5 years? So today, for example, what has the huge unlock is any kind of robot operating without a fenced environment or a cell. So in most of the car factories or logistics environments, you would always see a yellow fence, and the robot, like a Kawasaki big heavy arm, would do left or right, and that's very good. But it limited the adoption because the cell costs are huge. It's fixed. You have to actually make 10-year plan changes in that warehouse because you
Hmm.
create a change. But now the change would be, if people call it cobot, people call it lightweight robots. They go in, AI is capable now to pick up a task and not require that cell change. Uh, that is happening today. Now we fast forward a little bit and say, okay, what else is possible? Then you say, okay, well, it is doing simple tasks today. Now it can it do more complex tasks like assembling a gearbox, assembling a door latch in automotive factories. Those are harder tasks. But if you think about it, there is still very specific, and I'm still calling it 3 years out on that specific task. Nowhere, I think some of the people are perceiving it to mean that, oh, the robots are ready. I saw a demo of a humanoid jumping and doing something, and it can do 7 tasks in a home. That is very far out because the variability
Hmm.
in the environments, the task complexity uh, increases as the tasks get more difficult and the environment gets more difficult.
Yeah, true. So where does TorqueAGI sit across the stack, like infrastructure, application layer, orchestration, something else?
That's a very good question, and I was thinking about it. So I think robotics used to be very vertical. Like that robotics company would buy the hardware, wheels, and stuff, but otherwise they're building a full level of a stack. Um, and now this layering is happening a little bit in the industry as we see across the companies. So TorqueAGI is actually taking a approach where we are saying between the model AI, the end skill that is being generated. So not just the model, but taking the model and converting into what I call as module. And module implies that it has a very specific input and output and fits right into the robotics stack. So we see ourselves as a module which does a skill to the robot, does a task, and it consists of a model, agent, and certain other things, so it can run on the robot. We are not saying we are just doing the model part or the agent part or something. I don't think we are there yet. At least the way we are positioning Torque AGI to further differentiate between what it means for that skill to be broken apart.
Got it. Got it. Got it. Okay. A lot of AI at the moment can think right, but not do. We're starting to see that, like with agents, and then obviously moving into the physical world. What's required, in your opinion, to bridge that gap into real world action?
right? And there's a couple of schools of thought there. One is should the AI do an end to end, which is input to output, or should it be more interpretable so that once we deploy it in the field, we can measure it. We can measure how well it performs and calculate the risks and the
Mm.
harms, right? So, but at the same time, technology is improving very, very fast. So you have uh, open claw models and so on, which can take actions in the online world. You also have the VLA concept where vision language action is in the same space. So at TorqueAGI, we have chosen the models to be very powerful. So they can embed actions and planning, detection, perception all into the model. But when we say how to use it, we keep the agent separate. So you can still interpret what each module is doing, each step is doing. And the second part of your question is should the model perform action and at what level? So when you work with, for example, heavy machinery, so we are collaborators with John Deere, a tractor company, and they have like very large diesel motors. I mean, these are like
Hmm.
right, like 40, 50 years of engineering. And the question becomes, do we even want the model to output control commands for the robot, or should it operate at a kind of like a cost function and planning layer and let the tractors drive themselves, right? So I think there's no single answer. The models are capable of defining a strategy that they are good at. But
Yeah,
should they replace PID controllers of a motor? That I'm not sure about.
good point. Kind of leads me into asking you about how you think about reliability and safety when AI systems move from software into physical or operational systems, because you touched on also, the robots in the home and those safety concerns and things like that. Like, where's your head at with all of that?
Right. So AI is very interesting. So now, if you think about a model, it has the base, which is the architecture of transformers. Is it 64 layers? Is it this? Is it that? That's like very vector and tensor mathematics, right? Implemented in the GPU. But what really makes a transformer usable are the goals you set for it, right? What is it trying to learn? So in an online digital world, all it's trying to learn is what is called as a vector distance between two sentences. Like I am a this is an animal, this is a dog, they are close together. But if I say this is moon, it's slightly further away. That's the concept, right? But when you are building a robotics AI, we have to tell the AI what is important. And at Torque AGI, safety, component level measurability and interpretability is not a afterthought. It's designed inside. So when we build the AI, we tell it, this is your goal, this is your loss function, this is how you operate. So the AI is now learning with that. And the same concept of the agent, interpretable agents that we do, like you're not asking the model to do end-to-end prediction. At Torque AGI, we query it multiple times. First time is, oh, tell me about the boxes. The second one is, how should I go there? Third one is, how should I pick it up? So that lets you uh, measure how well it's performing and interpret it. And that really helps to put it in the field.
What do you think the biggest technical bottlenecks today are that are preventing true autonomy at scale?
There are, uh, so what is preventing true autonomy at a scale is partly related to a drift between two schools of thought. The one school of thought is let me just do pure data driven approach in the transformer, flat tokenize it. I don't care if it's 200 million, $2 billion of data. RT2 paper, they proved a concept that you can do this. Second school of thought is, oh, I know my robot, I know my task, I need to constrain it. Think about model predictive control at the very. So we wrote a paper in 2013 called Deep MPC. It combined the best of both worlds called deep learning and model predictive control. So the knowledge, the deep network complexity was tied to the constraints of a MPC model predictive control, and that worked very well for certain tasks. So I think at TorqueAGI we are doing it in a certain way, but as a field, we need to realize that digital AI shows us that you can build one AI which is very powerful for different robots, but it's different from physical AI.
Mm.
Physical AI has to understand how does the physics work, how does the robots work, and there's a lot of good knowledge into the application field. It doesn't mean we throw away one of them. It means how do we take the best knowledge and learnings from robotics, encode it as the goals or constraints or tools into the large transformer architecture, which still has to happen. It still has to happen on how do you do it properly, right?
Yeah. Yeah. Okay. You've been through multiple tech cycles in your career and everything you've kind of touched on in here. How does today's AI boom compare to the past waves that you've seen, like big data or even when cloud first came around on the scene?
Whenever a massive technology advancement happens, we see some early wins. And then there is a long tail of value created. So, for example, when you mentioned cloud and data infrastructure wins, there were some very quick early wins like streaming movies and so on and so forth. And then it took a long amount of time for it to percolate into the rest of the enterprises. So AI today is very powerful. It's actually, I think, very powerful. I sometimes call it the fifth best invention since the beginning of fire. So fire, wheel, the internet,
Yeah.
iPhone as a whole, and AI is the fifth one. Uh, so there are a lot of early wins, and we will continue seeing the value. So there is no winter in AI itself. The question becomes who can adapt to it uh, very fast. In robotics, though, I do think that there are very real value to be unlocked. So think about tens of thousands of robots, thousands of robots in each company. Robots is not equal to humanoids for me. Robots are any machine that is operating in the real world, AMR, a tractor, a robotic arm doing things in a factory. I think there's a lot of value over the next 5 to 10 years in that space.
Mm.
Uh, and we have to still find very particular new use cases that can actually function when it comes to humanoids. So in that area, we are very bullish on industrial applications that we see real dollar values about to be happening.
You mentioned, the 20-year out, you'll probably see those more general purpose or robots in the home and things like that. But do you believe like general purpose AI systems and even robotic systems will dominate, or will it still be like vertical specific systems winning in the real world?
What would usually happen is you have a general purpose AI that is, I think, far more value than a general purpose robot. So I think is the contrary opinion I have, which is people think that, oh, general purpose robot and why can't it do anything, everything, right? But then you ask the question, the AI is more important. Like the knowledge to do the task is general. We haven't built that yet. We are building it. Community is building it. Now it can be compiled or as people say distilled for different robot form factors that can learn from different robots, and that particular robot might be suited for different tasks, which is actually very true. So going back to farming, you certainly want a tractor to do the farming. Like human form factor is not the best to do 90% of the tasks in farming, right? Look at industrial environments. There are many other form factors which are useful. If you do think about inspection, for example, narrow pipes, drone inspection, oil tankers, and so on and so forth, every single form factor other than humanoid is the best one. Now, when you come to homes and you say, "Oh, what is the good form factor?" Then you ask the question: should it be humanoid or should it be a cute dog for certain things like company, which people are building? We already see some
Yeah.
of that. vacuum cleaner, does it really is useful to have a humanoid literally take up antique a vacuum, or should we just improve the vacuum cleaner? So we have to ask those questions.
That's it's a very good point. Yeah, it's a very good point. There's again schools of thoughts and arguments against both, but you can see if you have a heavy industry robot is much more useful than a humanoid for that application, whether it's pick and place of large pallets or whatever it is. But yeah, I like the general purpose AI viewpoint. Where do you think the market is overestimating progress right now?
I think the demos, some of the video demos have actually this is like opinion shared by many of the uh, CEOs, CTOs in the community
Hmm.
that these videos do a very disservice to the community. I saw a recent chart that how many humanoids are shipped in a bar graph, and every single one of them is for data collection purposes or initial test, right? Uh, and you see videos. So I think that is where the general public sentiment is very far apart from the experts. That said, I think there are then you have to find the gem in the like in a haystack or needle in a haystack. It's like, okay, well, which particular companies, which particular use cases are real?
Mm.
And there are people who are making very smart choices. So I was on a quick Q&A webinar with one of our colleagues from Avatar Robotics, and they were building humanoids which have wheels and for uh, industrial environments. Now you say, oh, could that work? The answer is it could, right? And that's pretty good actually.
Yeah, yeah, exactly, exactly. A lot less complexity, more stable, less
Was the
energy.
clear
Yeah,
ROI,
yeah.
and even in the home space, there are very specific robots. So we are working with looking at partners, and even something as simple as a lawnmower, commercial lawnmower. They are pretty not smart right now. Some human being is operating them, right? Um, and then last mile delivery robots. So there is a lot of innovation happening that will create real value.
Yeah, true. Where do you think that the industry is underestimating how fast things will move?
So, number one, that thing that comes to mind as a whole is um, the whole software development processes. I think that's obvious, right? That's like
Hmm.
clearly being replicated, bypassed, superseded by what you can do. Uh, People are also underestimating how many of the um, so whenever you have a situation where you have a robot already in a setting that is doing task number one. So it's the whatever red, green, blue robot doing things in the same task, and it is doing 2 out of 100 tasks in a warehouse. Now, what happens is that the you don't need to innovate on the robot form factor, the factory layouts, and so on and so forth. Now, suddenly you see robots going from two robots to 20 out of 100, maybe 40 out of 100. Now, that's a 10x, 40x jump into capacity. Uh, and that we will see so fast happening because AI can literally be a software upgrade onto the robot, and you are
Mm.
not running against the learning cycles and limitations of new robot form factors.
I hadn't thought about it like that. That's really interesting. Yeah, yeah. How do you stay disciplined as a founder when capital and hype are flowing aggressively into the space, and you obviously have a wealth of knowledge and experience and perspective that's unique on this? Like, I'm assuming it could be easy to chase the hype and chase the valuations and chase the investment. But what keeps you kind of grounded and disciplined on your journey?
I think I'm very passionate about long vision of the technology, which is a powerful model that is the right model, but it is also disciplined by non-hypotheticals, which is oh, can I collect $1 trillion worth of data? And if I am able to do that, then I will be able to succeed because I raised $10 billion. So, which is what you were referring to the hype. So, if we build something, we say, what is a sensible number? Can a customer give us X data points and can we build some outcomes? Now, that's the technology answer, right? Like, how do you approach it? But the real business is always tied to revenue, is almost never tied to funding. So we have seen a lot of companies, all of us have, right? Like they raise and then you don't hear about it after people tend to forget very fast. Uh, so the real metric is it at the end of the day changing a business metric? So in warehouses, it's almost always tied to throughput. So whatever task you're doing in assembly tasks or warehouses, can I do it at, if X is the current baseline, can I do it better? And if you do that, then there's real revenue flowing. So
Mm,
that is what is drives us. In fact, like we like customers who are deploying their 11th robot and is scaling to 1,000. We almost always find, unless the founder of that company or the CEO, CTO of the company has been in that area, that people who have deployed one, two, or five robots, so many of those companies don't even know what they don't know when they go to their, like, the next robot.
interesting. Yeah, interesting. What does a successful deployment of Talk AGI actually look like for a customer?
So there are actually three levels. The first one is, can we demonstrate that? That's the first step. You can do it in 2 days, 2 weeks, right? The next step gets harder. So we really insist on operational environment testing first. So half of our customers know that already, half of them we work with them to say what is good. So what it means is, it's actually it's a very funny story. So if you buy one of these robot arms that we are using in the research community, and then you use one of the common models that is out there, and then you say, what are the instructions to make it work? They literally say, in order to get this working, you can only use a yellow wood looking table, and here is a link to buy that. If you change that tabletop to anything else, that model would not function. And you look carefully in every single demo video, you would find one of those two colors of tables, because if you change that, it doesn't work. And that is the irony of demos versus deployment. And when you go to real environments, you will see boxes piled on top of
Right.
everything, and it's dark and lighting. So it always calculates backwards from data. It's like, you don't need data for training, but at least can we collect a non-trivial amount of real field data? And that's your test bed. That's the second bar to cross. So functioning robot and data set. The third one is the robot now operating into that field environment?
Mhm.
So nothing less than that is acceptable, because you can cook together demos in days, right? That's the challenge. That's the irony.
Interesting. I did not know that about like the tabletops and stuff like that.
I'll
That
send you a
makes
link in the following. So I hope
yeah.
you don't remove it, but I should take a screenshot actually. But
Yeah,
it's like,
please.
you please use this specific table, otherwise the robot won't work.
That's crazy. What separates companies that successfully adopt AI from those that stall out in the process?
I think the mindset has changed. So one organizational shift that we are seeing is, earlier this is very organizational grade, right? Like if you have a 100% company, what used to happen, and not just in robotics but also in any other company, you would have these focused groups saying, I am building X outcome, and I have a product manager, engineering team, I am responsible for that outcome, and you have many of them. You did have a basic IT provider internally to the company, and a little bit more of an infrastructure provider, but that it stopped there. Email was central, cloud services were central, certain other things were central, maybe data platform was central, but then it stopped there. Now you're seeing is a massive shift, and it's the story about the pre-trained power of the model has gone up from 10% in the last decade to 90%. It is very, very surprising. It's like earlier, that pre-trained part was 10 and you have to do majority of the work to build that AI. So that's why you can keep that vertical AI. Now, pre-trained model is powerful. So now what it means for industries is that they really have to think about what is my AI team. And even for a company which has nothing to do with AI or robotics, the answer becomes, well, my AI team might take 50% of the budget and do 90% of the work. So now I'm rethinking my org structure where I have a very powerful AI team which builds the AI or uses the AI or makes it possible to use. And then my application team are using it. And then a sudden surprise happens, like almost like a Cambrian event. So it's like one team is using it, second team is using it, third team, when they come in, they are very surprised at how does that AI know about my problem more than what I did. You know what happened?
Yeah.
Because the first two business groups are feeding it organizational information, and third one is much better already.
Yeah,
And
it's
that's the surprise
compounding.
that you're seeing.
Interesting. Are buyers, in your opinion, are buyers today like more technical, or are you still having to educate the market heavily on what you guys do, what the product is, how it can actually have an impact for them?
There are two personas of buyers. Uh, the good news is that the first persona hasn't changed in the for forever, right? As business persona, it's like if I purely put the persona hat, and sometimes two personas may be in the same person, but persona says, I don't care if you use assembly code or a foundation model. Would I get the outcome with the ROI? Would this thing work in the field? So that is fewer of the AI companies in the robotics area really focus on. Now, there are very good companies who are doing that. So we are working with some of them in the same space, and they really measure themselves on the performance in the field. Uh, the second persona is what technology are we building? Are we going towards the right vision? The good news is that I think actually, literally in the last 1 year of the company, we saw a huge resistance in 2025, early 2025, where people were, oh, they're the foundation model, but I'm going to keep using what I'm doing. So there was some amount of resistance. But this year, what we are seeing is they've realized that it's like massively far apart. Like foundation models and agents are like not just 20%, 2x, they're like 10x, 100x better. And when you are operating
Crazy.
at that level, so 90% of them are like, okay, how do we get there?
Yeah. Yeah. Before we wrap up the show, I really want to find out a bit more about the talent side for you, because obviously that's where I focus. Very important to me, and I think for anyone in this space building right now, it's a unique time looking at team building, what you can substitute with AI, and you mentioned before your agentic workflow, etc. What type of people, first and foremost, thrive at TorqueAGI?
And that is such a great question because uh, if you ask the same question 2 years back, I would have a different answer. Oh, we need very good programmers, we need XYZ. And now you look back and say, what do we really need? So, couple of things AI can do well, which is given a focused task, it can write the code. Uh, Now, the type of people at TorqueAGI, the two things that we really look forward in the team. Number one is agency. Agency means, do you have the drive to even prompt the AI and get your job done? Because AI is not going to prompt itself yet. So that motivation, agency of trying things out is like has become the most important driver, because you need experts in certain areas, but that becomes the number one driver. The number two thing that happens is this is new. So earlier you would communicate and make the team effective by talking, creating GitHub tickets, certain organizational skills, communication skills. But now with things like markdown files and shared projects, there's a whole new way of enabling the rest of the team and leaders, right? They do something with AI, and if they're able to share it with the rest of the team, that gets very, very powerful. So those two are, I think, new things. The rest of it still applies, that you may not need to program, but need to know what a good software architecture looks like, what a good mechanical design looks like, what a good interface looks like. So that those are the skills you still need.
Yeah. Things have changed so much on the hiring landscape. It's pretty crazy to look back at these last few years. When you're hiring in this AI and robotics world today, what do you think's overvalued and what's undervalued in candidates, whether it's like them personally or experience or mindset?
Um, so if I understand your question correctly, is what do you mean that generally people think of over?
Yeah, like, for example, I have some clients or have spoken to companies in the past where they're like, we just want people that have worked at Nvidia and Tesla, and that's it. And I'm like, okay, that's not, it's a good data point, but it's not the best. So they're overvaluing just the loose, if we want to put it, just caliber of people that have come through that hiring bar, regardless of, you know, background, what they've worked on, their mindset, ability in their environment. And then there's other people that completely undervalue softer skills or um, adaptability or agency, to use what you've mentioned.
Now, coming from a having a good history has a positive aspect, that you have some positive proof points towards what we talked about, agency, quality bar, and so on and so forth. But I think the problem with that approach, as you hinted towards, is uh, first of all, many of these things are new, and talent has spread across a lot. So when we look for candidates, we look for adaptability and agency and familiarity with new tools, which is often not found, for example, in people at a large company with a large years of experience, because you're not experimenting, you're not familiar with the new things. And as particular examples, some things that stay this require experience, and experience might be coming very fast for junior candidates, or it could come after years, is what I call as in AI metrics and quality bar. People may know how to write a prompt in AI or something, but they don't know how to measure it. Like just
Mm,
measuring the robot AI is a skill. Things that have actually flipped completely is so many people across the world now know how to build transformer architecture and do certain things, that is not tied to no longer tied to a large company, right? So we are very open in hiring candidates from variety of locations and companies.
yeah, yeah. Do you have any balance here or thoughts on how you balance like deep researchers or even just academic profiles versus builders who can apply it to the real world?
I really like people who your team is a team, right? So there are people who are builders, there are teams who are innovators, but at least at TorqueAGI, we are bringing the leading technology, building it to make it better, but productionizing it. So at TorqueAGI, we have no difference between an R&D engineer and a build engineer. We are taking the tech and building it to production. We are not writing papers. But some companies do split researchers versus others, which I think only works in very few cases in very large companies. So we like, I think, the we have PhDs, you have masters, you have experienced people. So we hire across the board in that.
Nice. All right, last one before we wrap here. I'm curious on your founder perspective here and what you think founders consistently underestimate when they're building in AI.
Uh, I think what they are many of the AI founders are underestimating the direction and speed at some of these other large companies are going. So a lot of companies start with a simple prompt and it's entirely superseded. So one thing to keep in mind is, what if one of the large companies like Anthropic and others do an upgrade? What happens? Now it's possible to compete with them, uh, what we have found is that if you're either innovating on the deep tech layer of transformers, or narrowing or choosing a set of application starts to help, because then you are retaining that vertical focus, and the value becomes, how do I take that vertical knowledge in the field and tie it to the transformer, generative AI, physical AI architecture, depending on where you are operating at.
Yeah. Yeah, I've seen so many of those tools, right? They're doing something very specific, then there's a new upgrade and no one's using them anymore because the adoption just wasn't there. And it's sad, but I mean it's also a very good cautionary note here from you. So thank you. Well, look, thank you so much for being on the show, Ash. I really appreciate it. This was awesome. It's great to get perspective, insight, and advice from someone who's got so much experience and has seen a lot in the space. So thank you. Appreciate
Yeah.
it.
Take care. Bye.
Yeah. How before you go, how can our listeners learn more about you and Talk AGI? Where can they follow and find out more?
We are launching and pushing on our blog called The Edge.
Okay.
So going forward, there will be more things coming out, more like education series about how to build physical AI the right way.
Perfect. Well, look, we'll list all of this in the show notes, and I look forward to seeing what you guys do.
All right. Thank you.